My name is Professor Brian Hutchison, and today we're going to be starting some of the exponent rules. So, what if I asked you to tell me what is x squared? Well, the x is my base, and that guy is my power. And what it means is we're going to take the base and multiply it by itself by whatever the power is, the number of times of the power. All right, so if we had x to the fourth, that would be x times itself 4 times. So if we ever had x to the n, what this means is I have x times x times x times ... itself n times. So my question is, what is x to the first power? Well, it's just x times itself 1 time. Well, that just leaves me with an x. And this is what I call one of our first major deals, is if you have 3 to the 1 power, guess what? You get a 3. So anything to the first power, well, it's pretty nice. It's easy to map out. So let's build up on our rules. What if I had x cubed times x squared? So this is going to be called the product rule. Well, using our definition of an exponent, x cubed is x times itself 3 times. And then I'm going to times again, using a different color, the x squared, which is x times x. Reversing our definition of exponent, that tells me this guy should be x to the 5th, because it looks like I have x times itself 5 times. Well, how do you get to a 5 using a 3 and a 2? Oh, we add. Right? This becomes x to the 3 plus 2, which yields me x to the 5th. So the trick on this one is we have like bases. If I gave you another problem and it was x squared times a squared, well, some of them are x's and some of them are a's. X squared times a squared is just x squared times a squared. We don't touch it. Ducks and chickens, they don't want to go together, right? Okay. They don't want to go together. So we leave it alone. So if I had x cubed, x squared times x to the 5th, what would I get? This would become x, because they're all base x, 3 plus 2 plus 5, which would give me x to the 10th. So the product rule is really based off of adding my powers. Don't let them mess with you. They try to do something like this guy up here. Ducks and chickens, don't mess with them. So this is called the product rule. Now if we have a product rule, shouldn't we have something with division? Well, we have quotient rule. Quotient rule usually deals with some divisions. Using our definition of an exponent, this is x times itself 5 times. We get this thing. As long as there's no adding and subtracting, right? I love fractions. If there's no adding and subtracting, I really love them. Right? Because what does an x on top in the numerator get to do with one of those x's in the denominator? Boom. They just cancel each other out. Boom. Those cancel each other out. And this just gets me left with x cubed. Well, how do I get to a 3 using a 5 and a 2? Oh, quotient rule says that I'm going to take whatever's in my numerator, the power of the numerator, minus the power of the denominator, which would give me x cubed. So we just do subtraction. Right, so just a little bit of a recap. Product rule says x to the m times x to the n is x to the m plus n. Quotient rule says if you have x to the m over x to the n, you get x to the m minus n. So what's another rule? This is probably one of the ones that is most often messed up. And we're just going to call this guy the power rule. And why does it get mixed up is, I'm going to drop the x. I'm going to go with some nicer numbers. So this is basically 2 cubed raised to the power of a 2. My base is 2. Now I want to keep my answer in base of 2. But what does this mean? Well, this says that I want to square 2 cubed. Well, that means to square something means you multiply it by itself. So I have 2 cubed times 2 cubed. Well, what's 2 cubed? It's 2 times 2 times 2. And this guy's a 2 times 2 times 2. And how many 2's are that? 6. How do you get to a 6 using a 3 and a 2? Oh, it's multiply. This guy is just 2 to the 6 because it's 2 times 2 raised to the power of 3 times 2. But the thing to note, it's basically a base raised to a power raised to another power. That's when we multiply. So when we see the power rule, they'll usually write it in this form. Now, is 2 to the 6th the number? Yes, but I was just getting tired of writing all those dang x's. So how y'all doing? So with these videos, you need to remember, they're not the primary for your learning method, right? That's homework, other instruction from the professors, etc., etc. This series is just about getting our feet wet. Getting our feet wet. So I gotta ask you a question. What is, I'm not going to do x, let's do a. A to the 0 power. Some of y'all might be saying, Brian, don't go wild, right? You're supposed to keep this easy, and I like this guy. It's a to the 0 power. What if I told you it's just 1? Whatever a is, it's just 1. And a lot of times they say x to the 0 power when some stipulations on x, but we'll let your higher math classes deal with that one, is equal to 1. Basically, something raised to the 0 power is 1. Well, how in the world do they get that? Well, what if I told you I had a to the 5th over a to the 5th? Anytime you divide a number by itself, exclusions of 0 and some other indeterminate forms, but you get 1, right? Well, isn't this just a times a 5 times over the same thing? And they all cancel out? Well, they don't go to 0. A divided by a is 1. This is basically 1 times 1 times 1 times 1 times 1 5 times, which means this guy is 1. Now, it's not, this isn't a proof because I picked a to the 5th, but what does quotient rule say? Quotient rule tells me this is 5 minus 5, which is a to the 0, which has to be 1. Right? Anything to the 0 power is 1. If I gave you negative 3x to the 0 power, you better write 1. Notice the parentheses. Because if I gave you this, for those of y'all that have followed along with some of the PEMDAS videos, this is technically negative 3 times x to the 0. And what do we do first, multiply or exponents? Oh, we do the exponents. This is negative 3 times, well, x to the 0 power is 1. This guy is equal to a negative 3. Those are two very, very sneaky guys. And I think this is where we are going to end the video, and I'm going to tackle the negative exponents next. Have a good day.